Icon is one of the most recognizable names in the 3D printed concrete business. Their highly publicized residences in Austin, Texas are finally complete, and I stayed overnight in one of them. In this video, we're going to discuss every aspect of the project, from the printing process to the architecture, interior design, air quality, and overall impressions. Before I begin, I want to thank Jared Gross for organizing this stay and for inviting us. You've probably seen some of his videos on 3D printed concrete, but if you haven't, I'll link his channel in the description below. The 4 houses are located in a rapidly growing neighborhood in East Austin. They were designed by Logan Architecture and developed by 3 strands. Once concrete foundations were poured, the exterior walls were printed with Icon's Vulcan printer. They used a proprietary cementitious material called Lavacrete. 1-inch tall and 2-inch wide beads of concrete were printed at a rate of 5 to 7 inches per second. The exterior walls have 2 layers, while the interior wall has 1 layer. All the starts and stops are hidden behind window and door openings. Vertical structural reinforcement was added inside the concrete walls. Excess concrete was used to make sloped lintels and frames for the windows. Any concrete used in 3D printing isn't actually concrete, it's mortar, because it doesn't contain gravel or coarse aggregates. I'm not sure how strong Lavacrete is because one page of Icon's website says that it has a compressive strength of 6,000 psi, but another page says that it's a more reasonable 2,000 to 3,500 psi. The printed layers are pretty even on straight runs, but they bulge out at window and door frames. This is because of the gantry wobble at turns. Some people might find it unsightly and would prefer smooth walls, but I'm glad that Icon didn't try to fix the mistakes. They embraced all the imperfections like small chips and wavy lines. The concrete walls, door, and window frames were painted with a white elastomeric paint. This liquid paint hardens into a flexible, watertight covering. It can also bridge and repair non-structural hairline cracks. I couldn't find any visible cracking on the exterior or the interior of the house. Only the first floors have 3D printed walls. The upper floors are made of traditional 2x6 wood framing. As I discussed in my previous video on 3D printed concrete, walls are a small portion of a building. Even though it took 5 to 7 days to print the first floor of each of these houses, installing all the utilities and finishing the exterior and the interior took several months. The use of color on the exterior of the house is very successful. The horizontally striated walls on the lower level are painted white. The upper level is clad in vertically striated black metal paneling. This draws your eyes upwards and makes the building seem taller than it is. The wood walls overlap the concrete walls, which makes for a very clean transition. It also marks a clear distinction between the 2 methods of construction. Another important design decision is the use of curves and rounded edges on the lower level and sharp angles and a traditional pitched roof on the upper level. It makes the building look top-heavy and gives off the illusion that it's actually a black house floating over a base. The buildings are very similar to the homeless shelters they built in Austin's Community First Village. Lastly, every single house on this lot is slightly different. Some have a red cedar siding, some have black siding. Their orientations and entrances are different too. It keeps you interested and looking around for more variations. As you can probably tell, I found the architecture very inspiring and successful. The interiors are clean and minimalist. Claire Zinneker, the interior designer, went for a West Texas vibe, or what I call Marfa chic. I think the exposed concrete walls are a classier version of the overdone wood shiplap walls. The roughness of concrete is contrasted by super smooth level 5 finish drywall. The unit that we stayed in had a half bath, kitchen, and living room on the lower level. Upstairs, 2 bedrooms are separated by a full bathroom. The kitchen cabinets, flooring, ceiling, and even the furniture were all a light wood finish with minimal texture. Since hanging any ornament on the concrete walls would damage them, sleek picture rails are attached to the edge of the ceiling. Frames are hung from transparent plastic cables. The designers came up with a very creative solution to hide electrical wiring, plumbing, and vents. They bumped out this wall and ran all the utilities through it. Unfortunately, the kitchen is set up against one of the 3D printed walls, which could make remodeling difficult in the future. Also, the joints at the uneven concrete walls are pretty rough. There are gaps at the edge of the countertop, the cabinets, and even the door frame. The spacing around the door frame is also uneven. That's just the reality of 3D printing right now. It's not perfect. Even though the wind was howling outside, the moment we stepped in and closed the front door, it was wonderfully quiet. The 3D printed walls have a layer of open cell insulation in between, but also rely on thermal mass. Apart from the door and window openings, the inner wall never meets the outer wall, which reduces thermal bridging. I used a FLIR thermal imaging camera to see if there was any heat loss or gain through the walls. The living room downstairs was very well sealed. There were no obvious leaks at the base of the walls, the ceilings, or even around windows. However, you could definitely see some thermal bridging through the wood studs upstairs, which is pretty typical. This shows us the advantages of using concrete construction over traditional stick building. The house is very well insulated and very comfortable. Positive Energy designed an ERV, or Energy Recovery Ventilation System, which brings in fresh air continuously at a rate of 70 cubic feet per minute. An air handling unit circulates this fresh air throughout the house. The bathrooms don't have a traditional exhaust because of the ERV system. I spoke to the engineers who are fully confident in the sizing of the ERV system. However, when Jared Gross, a neighbor, my husband, and myself had dinner together in the living room, my AirThings sensor said that CO2 levels spiked and remained elevated throughout the night. The VOC levels were also high, probably because of the new furniture. I was there for less than 24 hours, and those sensors take a couple of days to properly calibrate, but it's still something I'm concerned about with airtight homes. Now, the one thing that everyone is most curious about, the cost. All 4 units have been sold and will be rented on Airbnb and VRBO. These 2 units are around 1,000 square feet. They have 2 bedrooms and 1.5 baths and were listed for around $450,000. The 1,500 square foot house, which has 4 bedrooms and 3 bathrooms, was listed for $745,000. The largest house on the lot, at 1,900 square feet, also has 4 bedrooms and 3 bathrooms and was listed for $795,000. All these are pretty comparable to the cost of other properties in the area. Y'all know how cynical I am about the claims made by the 3D printed concrete industry. But these houses really surprised me. I was very impressed. The entire project is very refined and well thought out. Every company involved seems to really care about its outcome, how it performs, and its future. They take pride in these homes and they want the inhabitant to feel that same sense of pride. Icon even embedded a medallion at the entrance to the home, which says that the home was designed with love in Austin, Texas. The name of the printer used and the building number is also on it. As much as I love the architecture and the site layout, I was disappointed that they printed mostly straight walls. They didn't explore the 3-dimensional capabilities of the technology. The homes could have been built with CMU block walls or precast panels, but those walls aren't as enticing as 3D printed walls. Also, Icon seems to be pursuing refinement and economies of scale rather than design exploration, which is a legitimate business strategy. I was also disappointed that they tried to integrate electrical wiring into the walls. I know companies see it as a challenge, but I'd prefer to see free-form undulating 3D printed walls separate from the interior partitions and utilities. Because the concrete wall is uneven, some of the wall plates were loose. They definitely need to improve the consistency and smoothness of the printing process, but I can see this project becoming a historic home 50 to 70 years from now. I'm also very interested to see how this home and all other 3D printed concrete homes age, how they hold up over time. I tried to address all major points in this video, but if you have any other questions about this project, leave me a comment below. I'll link my Patreon page in the description. If you can support me, I'd really appreciate it. A big thank you to everyone already supporting me. Don't forget to hit the like button and subscribe to my channel. Thanks for watching. See ya.